I, this is an optimization problem, and Anthony, you're going to take us through it here?
Okay, so here I have a farmer's pen. You're looking at it from a bird's eye view, so you can see the bottom. What the farmer wants to do is he wants to take this 1,000 foot of fencing, that's all he has, and he wants to make 3 equal compartments for ducks, cows, and goats.
So each of those 3 little fenced-in areas are supposed to be the same size,
Exactly
and he's
same
making a
size.
rectangular fence.
And he wants to make the area or spacing for all of them as big as possible.
As big as possible. Got it.
So we're going to do a bunch of equations to see how this works. Okay, so I'm going to put it as like a graph. Each of these I'm going to make it as y because they're vertical.
So he needs like 4 y lengths of fence to
And
build it. Okay.
Top and bottom, obviously x. Nice.
2 x lengths of fence. All right.
Now for the perimeter of the whole thing in general, including these little parts, would be 1, 2, 3, 4 y plus 1, 2 x, which equals 1,000 feet. And since we want area as big as possible, we'll put the area equaling x times y.
So you want to maximize that area.
Yes.
Okay. Fabulous.
Since I don't really like having 2 variables in the area because it kind of messes up.
Me neither.
I'm gonna.
Yeah, that's bad. 2 areas.
I'm
2
gonna
variables
change
bad.
this in terms of one of the variables, so I can substitute it in, so I can have in terms of 1. I guess I'll just do it with x. Why not? X is the next number.
That doesn't matter, right? You could
Right.
solve that top equation either for x or y. Makes no difference.
So I'll just move this over here. 4y plus 2x equals 1,000.
Nice.
Subtract 4y on both sides. So 2x equals 1,000 minus 4y. And divide by 2. So we can get nice x equals 500 minus 2y. All right. Thank you very much. We have x. X I'm going to plug in right into this area equation. So A equals 500 minus 2y times y. So now we have in terms of y, to the whole distribution, we get 500y minus 2y squared. Now, that's
So
all
beautiful. Area equation, 1 variable. Terrific.
Yes. Now we're going to use the derivative. Ooh, derivative. No one's heard of that before. So a prime equals 500 minus 4y. Now, that's that. So, we've been learning about critical points. And so we want to find a critical point, either min or maximum, of this scenario to find the best possible y value for this situation. So we're going to put this in terms of 0.
Right, because critical points are places where the derivative is 0 or undefined, but okay.
Add 4y on both sides. So 4y equals 500. Obviously divide by 4. Since I'm a math genius, I already know that y is equal to 125. I'm sorry, I just know that. Now I want to figure out if it's a minimum or maximum. So, oops, sorry.
Maybe you could bring it back over here. You're drifting off the side of the board there.
Back here. So what I'm going to do is I'm going to make a little graph, like a little number line.
So really, this part is nothing new. You found the derivative. You set it to 0. You found a critical point at 125, and now you're just going to check both sides, pick any number on both sides, and make sure you found a maximum.
I'll go big. I'll go 0 all the way over here and 200 because it doesn't really matter.
Doesn't matter. Anything on that side, great.
So I'll start with 0 because I know this is 0. I'll start with 0. I'll do 500 minus. Sorry, I'm losing my vision. 4 times 0, which is just 500 minus 0 or 500. It doesn't matter that's 500, it matters that it's a positive number. So plug it in, it's positive.
So wait a minute. So you stuck 0 into the derivative, and you got a positive value. Terrific.
Now, same thing with 200. You got 500 minus 4 times 200 is 500 minus 800, which is negative 300. Doesn't matter that's 300. It matters that it's a negative number. So, bam, negative. Now, if I wanted to make a graph on the side, no, whatever.
Just draw it right on top of what you have there.
Okay,
I mean, that's terrific.
Why not?
Why redo the whole thing?
Okay, so we got the 0 right down the middle. So I have a positive slope. That means it's going upward, and then 0, and then negative slope. And then right here, you have a critical point that happens to be a local maximum. It's up. Now,
Yeah.
you know
Oh,
that,
all right. There's
you
more.
know that in
Okay.
this situation, it is the highest possible y value in the situation that you can use. And then now that you know that 125, which you got from here, is the highest you can do, you can plop it right into this equation. So 4 times 125 plus 2x equals 1,000. This is obviously 500, math genius, you know. Plus 2x equals 1,000. Subtract 500. Some difficult math right here. Don't get lost with me. 2x equals 500. Divide by 2 on both sides. And you got x equaling 250.
Nice.
So now...
So those are your max 250 by 500?
250, yes. By 125.
By 125, I'm sorry. That is guaranteed to be the dimensions which will maximize the farmer's fence there.
Beautifully biggest area, perfectly.
I love it.
Happy ducks, happy cows, happy goats, and eventually happy farmers.
Thanks, Anthony. So Sergio, you're very similar problem to the one that Anthony did, but there's a slightly different twist on it, right? This time, in fact, we know that the farmer wants to have a total area of 800 square feet. It's chickens this time also. Very nice touch. Okay. So this time, you want to write that down? This time the farmer wants a total area of 800 square feet, and he wants to do it using the minimum amount of fencing possible. He wants to make it cheap. Sure. All right.
He's a farmer.
He's a farmer. He's trying to be cheap. All right. I'm not implying that farmers are cheap, but everyone's frugal. All right.
Okay, that's one chicken.
Alright, so we got area equals length times width. We got, that x is
So
y.
just like the last problem, you're labeling x and y. That's terrific.
And then 800 feet squared
Right. This time we know the area.
equals xy. However, we want to get rid of one of those variables. So why not get rid of y?
Sure. So
Let's divide by, I'll just do this.
you can divide both sides by y. So in fact, you have x equals 800 over y. Great.
Boom.
And now you need the other equation. Actually, why don't you move over towards your right there a little bit, right underneath the other one. So what are you going to do now that you have x by itself?
perimeter.
Right. The amount of fencing. How are you going to write that equation?
Like my esteemed colleague Anthony did before.
Good.
So he needs 4 y lengths of fence and 2 x lengths.
But since we have y is y and x is 800 over y, we have perimeter equals 4y plus 2 times 800 over y.
So fabulous. So now you have a perimeter equation with one variable in it, and we want to minimize it. Now you put p there for perimeter, but it's really amount of fencing. It's really not. It's really includes the inside fences and stuff. Right. Okay. So that's the amount of fence. So how do you find maximum or minimum?
A derivative.
You need a derivative, and then you're going to find where it's
Love
0.
those.
Yep. You have room over to the right there if you want to go over to the right a bit. So take the derivative and
Bring that upstairs and make that 1600
terrific. So tell us what you're doing there.
Solving for the y.
So you found the derivative, you set it equal to 0, you wanted to find, then you were solving for y there, okay, so what'd you do?
One
You
more step.
square root and y equals 20, fabulous.
Make that little number line 20, critical point, which means that the slope will be 0. And now we're dealing with slope, not so much values, but slope is 0 here. Take a number like 1 and 100.
Good choice.
But take that, the derivative. So 4 minus 1600 over 1 squared.
Well, it's definitely going to be
4 minus 1600.
negative, big time. Doesn't even matter what it is.
So,
Some negative value, and pick something on the other side, like 100 you put in.
10,000 there. So 4 minus 1600 over 10.
And that's going to be a rather tiny number, 16/100ths. 4 minus 16/100ths. Well, that's less than 1. So that's definitely going to be positive.
4. So yeah, it is.
All right. So in fact, it goes downhill, and then then it's flat, and then it goes uphill. So you have found a minimum. So now is 20 the x or the y value?
Y value.
20 is the y value, so that's the length of those y values. And if you wanted to find x, you don't even have to do it, but if you wanted to find x, of course, you could plug in 20 into the original area equation there, couldn't you, way back over there?
So area equals xy 800 equals x times 20. We look at 20, 20,
And x equals 40, and those are the dimensions.
Awesome.
Fabulous. Okay. That was beautiful.
Awesome.